Now, as we stand on the threshold of the 21st century, it's time to escape from the past. Let's consider this aluminum bar. We will run an experiment to see if ALGOR's AccuPack VE virtual engineering software can predict if the bar will hold up or fold up when a weight is placed on one end of the bar. We will use this mechanism, the Universal ALGOR Testing Machine. The bar is hinged at each end, by this hinge here at the bottom, and by this hinge in the carrier at the top. Note how the carrier, which can hold a variety of weights, slides along these vertical rods. In this experiment, we will have a weight on top of the bar. This weight will be held in place with this electromagnet. When we release the weight, it may cause the bar to buckle out to the side. The bar would impact this 2x4, which will serve as the floor. Let's now model the experiment using ALGOR's AccuPack VE to simulate this event and predict the maximum weight the bar can handle without buckling. Our plan is to see what will actually happen through animation on the computer screen. This "what you see is what you get" scenario is what we call virtual engineering. Then we will do the live experiment and compare the results with those predicted by the virtual simulation. We are starting out with roadmaps, ALGOR's Java-based, easy-to-use human interface. Now we select SuperDraw 3. SuperDraw 3's user-friendly features let us easily and quickly build this model. We simulate the effect of the hinges or joints using these small wedge elements. Using the FEA Add menu, we fix these nodes on the wedge and thus create a hinge. We constrain the top hinge to move along a vertical line, just like in the physical experiment. We do not know in advance which points on the bar will contact the floor. Therefore, in this case, as in many impact problems, the use of contact elements is not desired. What is needed is the ability for the points on the bar to contact the floor automatically. All the user has to do is put in the location of the floor. The software will automatically predict which parts of the bar will actually make contact with the floor. We will do 2 runs, one with 16 pounds of weight and one with 20 pounds of weight. Using ALGOR's new monitoring capability, we can see events unfolding on our computer screen as results are computed. After each run, we make a computer animation from the results. Here is the result of the run with 16 pounds in 1/4 time slow motion. Buckling is not predicted. And here is the results of the run with 20 pounds. It predicts several things. First, the bar is indeed buckling under the 20-pound weight. Second, a very large deformation has occurred. Third, the bar did contact the floor, which constrained it and forced it into its final shape. Let's further examine the significance of the floor. Without it, we still get buckling, but it is nothing like the correct simulation. Finally, modeling the removal of all the weight, we obtain the permanently deformed shape. Measuring the distance between the 2 ends with SuperView, we obtain 16.5 inches separating them in the permanently deformed condition. Let's go back to the experiment and see how well we predicted the event. First, we will use a 16-pound weight. Pressing the button releases the weight. Note that the bar supports the weight as predicted. Now the same test with the 20 pounds of weight. Again, pressing the button. Note that in fact, the column has indeed buckled as predicted, we do have a very large deformation, and the bar has contacted the floor, forcing it into the final shape. Let's do an instant replay in slow motion. As you can see, the AccuPack event simulation and the actual event match closely. Let's remove the bar from the apparatus so we can measure the permanent deformation. Observe how closely AccuPack VE predicted the permanent deformation. Predicting the event you just saw with the finite element system could be a formidable challenge. One of the more challenging aspects is predicting the contact and the subsequent separation between the bar and the floor. With AccuPack VE, however, all we had to do was build the model and specify the location of the floor. There was no need to put in special contact elements. Everything was automatic. The AccuPack VE event simulation, the actual event, the case solved. Virtual engineering and automatic contact from ALGOR for engineering in the 21st century.